evaluate limit x tends to 0, x to the power of x. In order to make the simplification easy, what I do is I'll take this limit as some value y. So y is equals to limit x tends to 0, x to the power of x. And let us apply logarithm on both sides. If I apply logarithm, it will be log y is equals to limit x tends to 0 log x power x, which can be written as limit x tends to 0 x into logarithm x, since the reason is log a power m equals to m times of log a. Now, if I substitute x as 0, it is 0 into log 0, whereas log 0 is undefined and we cannot use L'Hospital rule here. So in order to convert it into 0 by 0, what I do is I'll write this limit as logarithm of x by 1 by x, so that it is in the form of infinity by infinity and infinity. Now we can use this L'Hospital rule. So let us differentiate the numerator and denominator separately. Differentiation of log x is 1 by x. Differentiation of 1 by x is minus 1 by x square. So this is nothing but limit x tends to 0 minus of x. Whereas the value of x is 0. If I substitute minus of 0, that is nothing but 0. Hence the option is B.
Is the diode D has threshold voltage, that is V cut in, is equals to 0.7 volts. This is 0.7. And the forward resistance RF is equals to 20 ohms and ID equals to ID. We have to find out the value of ID. See, this problem can be solved in different ways. One method is we can find a threshold voltage here, that is VTH and RTH, and replacing this network with Thevenin's equivalent circuit, we can solve for ID. One more way is we can apply a KCL here, assuming the diode is on. Okay, so if we apply a KCL at node Vx, if we get ID that is positive, then the diode is in on situation and we are going to know ID, what is the value of ID. That is Vx minus 9 divided by 600, Vx 300, Vx minus 0.7 divided by 120, because the diode contributes 20 ohms resistance in forward condition, so is equals to 0. So if we take 600 as an LCM, so Vx minus 9 plus 2Vx plus 5Vx minus 3.5 is equals to 0. So 8Vx is equals to 12.5. So Vx is nothing but 12.5 divided by 8 ohms. So ID is nothing but Vx minus 0.7 divided by 120, which is, so Vx is nothing but 1.5625 volts. If we substitute here, then we will get it as 7.19 milliamps. Hence, option C is correct. We have to find the value of the voltage V across 5 kilo ohms resistor. Here, V is nothing but minus 10I2 into 5 kilo ohms. So, if we know the I2, then we are going to know the value of the voltage across the 5 kilo ohm resistor. So, for that we have to find out I2, that is I1 plus 10I2 is equals to I2. So, minus 9I2 is equals to I1. So, I1 is nothing but 36 volts divided by 20 kilo ohms. So, I2 is nothing but minus I1 divided by 9, which is minus 36 divided by 9 into 20 milliamps, which is 9 fours are 4 fives are. So minus 0.2 milliamps. So V is nothing but minus 10 into minus 0.2 milliamps into 5 kilo ohms. Kilo milli going to get cancel each other into 5. So this minus gets cancelled. That is we will get it as 10 volts. Hence option B is correct.
Of AC potentiometers is done by. Okay, AC potentiometers consists of dynamometers. Okay, since dynamometers work on AC, okay, we don't have any PMMCs. We will use dynamometers and one standard source for calibration. Okay, that means for standardization we will require one standard source for calibration and dynamometers. Okay, this dynamometers is also called as transfer instruments. Dynamometer is also called as transfer instruments. Okay, so for standardization of AC potentiometer is done by using standard source. This is of DC and transfer instruments. So option B is the correct answer.
System shown below, the number of poles on RHP, LHP and J omega axis or respectively. So in order to decide where are the pole locations, we have to write the RH criteria for the characteristic equation. Here C of S by R of S is nothing but a closed loop transfer function. So characteristic equation is S power 4, 4s cube, 8s square, 20s plus 15. So RH table is S power 4, S power 3, S square, S1, S0. This is 1, 8, 15. Here 4, 20, 0. That is 32 minus 20 divided by 4, 0, 0. This is 20. Here this is 15. Okay. This value is equals to 3. So 3 into 20 minus 4 into 15 divided by 3, 0. This is 15. So the value of this particular element is 0. So we have to 3s square 15 d by ds, we have to make it 0. So 6s is equals to, so the value of this element is going to be now 6. We have to replace S1 elements with 6, 0, S1 row with 6, 0, 0. Now here 15 is 15 as it is. So there are no sign changes in the first column after replacing S1 row with elements 6, 0, 0. All are positive sign, no sign changes, means there are no poles on the right half of the S plane, but there are poles. 3s square plus 15 is equals to 0. So s square is equals to minus 5 plus or minus j root 5, means there are 2 poles on j omega axis, means 2 poles on j omega axis, and the order of the equation is 4, means there must be a 4 poles. Out of the 4 poles, there are no poles on the RHP and the 2 poles on j omega axis, means 0, 2, 2. Hence option B is correct.